So let's get started. So today's talk is going to be on Tinkerbell and not on macros. Usually it was a bit the other way around. I never quite was able to separate these things. And yeah, I'm just kind of going to try to explain what this is, because just recently Clemos said on Twitter that he kind of likes this stuff, but he's too afraid to use it. So if you're feeling the same, somebody's taken control of and doing things. Tinkerbell. Yeah, it's magic. Okay. Geht's nicht besser? So yeah, okay. But first I'm just going to share a few thoughts on programming that actually drive me in making this library. So a warning to start with, don't believe anything I say. Usually I change my opinion every 2 or 3 years. So even when I'm quoting or misquoting clever people, it doesn't validate what I say. The implication may just be flawed. But don't believe those people either, because I've seen many clever people say just things that are also, well, that I believe to be wrong, then again. So just try things for yourself, and please start with those that you find most revolting, like the things that you fear most, that you think like it's counterintuitive, do that. Like, for example, work without an IDE. For a year I did that, it was very funny. So the most important thing I think to realize about programming is that we all suck at this in some way. And if you don't think so, then ask yourself this question: would you really put your life in the hands of products made as well as we write software? I wouldn't. I mean, there is some good software, but it's usually, for software to be as reliable as buildings nowadays, we make the same effort as the Egyptians did some 6,000 years ago. So the pyramids are also very robust, but you know, it took some doing. So I maintain that we are not engineers as yet. It's a worthy goal, but we are not at all there. And so I'm saying this because it's important to understand that all the methods and things that we are talking about are often shortcuts, because it's important to understand what engineering is really about. And when we look at engineers, we see a lot of tools, methods, and things like that, and we say, oh, okay, those guys are engineers. And when we look at scientists, they have complicated language, and so that makes science for us as outsiders, but that's like not really the core of things, because like biology is not about microscopes, and astronomy is not about telescopes, and physics is not about lasers. I mean, lasers are cool, but it's just not the thing. This is just stuff that's on the outside, and when it comes to engineering, according to Wikipedia, comes from ingenuity. So to generate into existence, to invent, kind of, to try something new. And then you're going to use all these tools to do that. But it's important to start from that, and I think nowadays there's only two extremes. There are people who say like tools don't matter and methods don't matter, and we're just going to do this. Yeah. And there's other people who say like, let's all be super enterprisey and professional and whatnot, and have a great vocabulary for that. I guess it's important to balance these things. So, okay, that doesn't fit there. So like this is a great quote from Structure and Interpretation of Computer Programs. Anybody not know it? No? Perfect. So let's just skip ahead. If you don't, I'll put the talk online, and then, yeah, watch the stuff. It's really great. Or read the book or anything. So yeah, I was speaking a bit about methodologies, and I was saying that like the best way to think of them is that maybe they are orthogonal to programming, and spanning the whole field of software development as a whole. And it's my experience that those that are about programming often introduce new problems rather than solving them. And the ones that really work great are about communication, because most programmers really suck at that. So it's good to have some process that forces us to review each other's code, to talk with one another, to formalize what we are going to do next, because otherwise we just lock ourselves into a cellar and then come out with something that may or may not be useful 2 weeks to 2 years later. What I think one thing that's important to do is to embrace nothingness. Yeah, here's some nothingness for you. Okay, but I'm going to fill it with something anyway. So here's the list of all proven methods to avoid bugs in code. And so please, like, it's really great to start out with an empty slate and not have to do anything, because you can start reinventing things and everything, and there's not all this rotten code. But do not ruin that. Like, it's the first thing that we like to do when we come into a new environment. Put in stuff that we are going to use later, and this is going to be, oh, this is going to be so great, and no, just leave it that way. That's very important. Because the code base usually becomes a terrible mess all by itself, and you don't need to help. Okay? Don't. Just leave yourself the room to maneuver. Don't add things later. And one other thing is, try to trust your fellow programmers. I think many people don't do that. It's probably based on arrogance, at least for me. So just in their willingness to learn and grow, and their ability to complement the code that you write, because people are usually just trying to solve the whole thing, and here you go, and then everything is going to be superb. And even like when you have people that seem to believe stuff that you think is completely wrong, they are still not going to be incapable. They just have a different opinion. But if they are posed with a real problem, then they can solve it. So you should never impose any decisions of somebody. Like when I heard that, for example, Thumbe imposes DCE, I don't think that's such a great idea in the end, because people should just know. But then again, I'm not going to impose my view on that. And don't consider yourself smarter. I mean, I don't know. I suffer from the feeling sometimes that I am, but that's really like hard to tell for anybody. It's just cognitive bias. But the thing that helps me most is to think of this as a wrong perspective, because there's always like people who are 1,000 times smarter than you are, and that's where we should look, because right now we know very little. I think right now we are maybe what chemistry was when it was still called alchemy. And so that's why we speak of magic a lot, and that's something that should be alarming you, right? And never be afraid to ask questions. I mean, I sometimes get the feeling that a lot of people just don't want to ask and head off in some direction, but that's like, just get some input. Okay, this quote, I guess in France everybody knows that. I just want to briefly touch on these two subjects. So I think it's important to understand that implementing things that may be useful later are a form of premature optimization. Because adding things to a lean system is easy, but when you get this big thing that somehow almost does what you want, but then you need to do it something exactly, then usually it's going to be a horrible fight. So, I mean, that's a problem that I've been in a lot of times, like some people, and me including, had a lot of infrastructure that later just killed us. And one thing that people don't talk so much about when talking about Yagni is to be aware of adding some implicit assumptions that you don't necessarily even see when you first design something. And so HTTP is the example that I will talk about. It's a hypertext transfer protocol. And the second thing is like the weird thing, because nowadays most of the stuff that we transmit is not text, much of the stuff is binary. Jonas just had, I think last week, had some big issue just loading binary data over hypertext transfer protocol. And that's like because, you know, the idea was, okay, people are going to load text, and in the 70s that was a great idea, or 80s, or I don't know when, like a long time before I even lived, probably. And this gets propagated into the Haxe standard library, you know, and at some point it's going to fall on your feet. So be extremely aware of the implicit assumptions that you do. You might not even see them, but they are there, and at some point you want to change something, and it's going to bubble up, and somebody else is going to pay the price. And KISS I was mentioning, so this is not KISS if you need to cut and pinch. And this is. And what's beautiful in programming is that we are not restrained by the laws of physics so much, and you can always like put these two together to make it a tool. You know, that's called the facade pattern, but just really have one thing or the other. Because I see this a lot in many great Haxe libraries, that they solve every problem for you, and they duplicate this over and over again. I think it's a pity. So always strive towards simplicity, and that doesn't necessarily mean ease of use. Like you can always make a wrapper to make something really easy to use, but first make it easy to understand what's going on in there. I still think like documentation is super important, but if you need to go into the code to check whether that's where some bug is occurring, then you should have a chance to understand what's happening. When in doubt, keep things small, like not like code golf small, but try to maintain a low cyclomatic complexity, like all these kinds of things. And beware that oversimplification is not good. It's like going too far. It doesn't make simplicity, much like perfectionism doesn't produce perfection, but it also just goes elsewhere. So this quote, I guess everybody knows. 2 different ways of constructing a software system. So simple that it obviously has no decisions, or so complex that there are no obvious deficiencies. And I mean, I think this is also nicely summed up in Divide and Conquer, and there is some evidence in our history, particularly here in Europe, that it works. So maybe that is something, if we manage to apply that to programming, then we can start to stand on the shoulders of giants. This is also, in some sense, known as separation of concerns and the single responsibility principle. And I want to dwell on that just one moment. If you look at Wikipedia, it has the first part is just a tautology. It's the principle that everything should have a single responsibility. But then the second sentence goes, and that responsibility should be entirely encapsulated in the class. And that's important to understand, because many people, when they modularize code, what they do is that the responsibility gets spread out over many classes. And then you have like these half-functional things, kind of, and they serve no purpose. And if you got to follow through the code, then like control gets transferred from here to there, to there, to there, to there, just to accomplish that one thing. And I mean, the tricky thing is actually having a mental model where responsibilities are nicely dissected. I mean, but there's just no simple solution to that. It's just something that you have to live with. And try to keep a beginner's mind, because in the beginner's mind there are many possibilities, in the expert's mind there are few. So let's have a look at Haxe. I think it's something that I think to have learned many things from, but I'm not saying that this is any of this drove its design. So one question that I'm always asking myself is whether Haxe delivers the promise that Java failed to keep, which is a complicated question that I won't go into, because maybe Java even did not fail to deliver it. Some people think that. And maybe Haxe does not, but okay, for now it does. And I think one of the reasons is its smallness and size. I mean, this is just an arbitrary metric to compare the two projects, but if you have the OpenJDK, where you can see 200 contributors for 5 million lines of code, and Hex you have 66 contributors for 130 lines of code. You see that's a lot less stuff to maintain, a lot less code that rots, and we can move faster and all these kinds of things. And still have like a lot of functionality. Like if you add NME and Flambe and I don't know, whatever you want to the other side, maybe at some point you're going to get to 500,000, you know, but like it's still an order of magnitude smaller. So that's I think that's something important to keep in mind when your code becomes bigger, whether you're maybe just not heading the right direction. And so we have, one thing is we have no short lambdas in Hex, which comes up every now and then. But I think what's not in Hex is as important as what is, because like omission is very important in design. So you just add the things that are necessary. And also, yeah. We can have it. I mean, it's incredible the amounts of things that you can implement with macros. Like David Peake did C-style for loops, and there's this and that, abstract classes. Whatever it is that you want, you can actually add it. I will show a few things. And so, yeah, I mean, that's the important thing, because macros are not easy to use. Okay, maybe. I mean, I guess, yeah. In the beginning, they certainly weren't. But in a way, they are actually quite simple once you get to understand it, and it's amazing what you can do with it and where places it can take you. And so we're going to bend Hex. And what's important in saying that there is no spoon and there is no Hex, there is no single way to write Hex. I mean, a lot of people in the community, they want to have one style guide, one way of doing things. There is no such thing. I mean, this language amazes me since I have really started using it. I'm starting to understand it less and less, like the scope of things. It seems to, well, also because Hex is growing, feature-wise, but it's just, yeah. Sometimes I look like that guy. So to what end? This is what we want, superpowers. And so we can use that flexibility and start shaping Hex a little to something more filigrane and make it lighter, and then it becomes a fairy. So, yeah, this is the new logo. It took me some time. So what it's not, and never going to be, it's not one framework, like any particular, like the title is maybe Hex on Wings, which is a riff on Ruby on Rails, but Rails constrain you, and Wings take you anywhere you want. I never want to tell people how to organize their code or do stuff like that. If I ever do that, please come and punch me or something. And it's never going to be finished. So what it is continuous work in progress with many small, well-documented packages. The stuff is all on GitHub Hextink, which is just an organization currently containing just me, but if you want to join, please do. And so these are the packages that I will that are ready to use. I haven't yet put all of them on HexLib, but it's going to be there this weekend. And so here we see kind of the stuff that's like the lines of code and the lines of documentation. I don't write inline documentation because comments are really just for me. They are just explaining the difficult parts or stuff that should be to-dos and things like that. And the percentage is like the ratio between code and markdown in bytes, basically. So you can see some of the things are really quite decently covered. And the documentation goes into why these things happen and has a few examples, even tutorials of, well, tutorial-like fragments. And you can read through all that stuff. So Tinkerbell core, I will touch on that just for a moment. What it does is just define some primitives for error handling and asynchrony, or reactive programming, as some people call it, laziness, and signals. I guess many people use signals by now. Okay, who doesn't? Whoa, cool, old school, like it. And so the philosophy is composability, composability, composability. But there's other stuff that this does from HX, which Justin will talk about just after the break. No, tomorrow? Just after the break? I don't know, but later. M-signal for signals, like check out other stuff. There's a small difference, like the slides will be online. There's actually a link to a discussion that I had with Justin on some design decisions, which are just varying between the two approaches we're taking. And so, for example, if you compare signal to M-signal, what I cared about most was not to emulate the AS3 signals and things like that, but for example, to be able to compose signals, to join them together, to have map and filter operations, which you know from arrays and things like that. And but the interface is very simple. Like, for example, the signals are not pausable as the M-signal signals, but this is how you can make a signal pausable. So you take a signal, and then you're basically going to filter it through a function which returns true or false based on some state. And unpause it, you can just, put this stuff together. Over here is another example of composing. Like, suppose we have this kind of buttons, two of them, and so we can take the up button and the down button and map the one to -1 and the other one to 1, and then join these two signals together. And what we're then going to have is one signal that just has an int. So, for example, when we want to take two buttons and make a numeric stepper, we can just put these signals together rather than usually register some event handlers, and then you're going to dispatch a new signal somewhere else, a new event, and this way you just put this kind of stuff together. All right. Tink macros I'm not really going to talk about. There's a lot of documentation, and what I want to talk about is the Tink language extensions. So let's just dive into that. So the way you use these is you just add implement Tink lang to an arbitrary class, and that gives my code the possibility to do some magic, and the syntax is then applied to the class and all the subclasses in turn. And here we see just some simple example, like for example this defines a point class with an x and an y, which are optionally initialized to 0.0. But this syntax means that actually this is going to be a constructor argument that is optional. And there you have a purely calculated property. So what that's actually going to do is going to make it get never, and then define the getter, and that's going to be there. So like the class would usually be about 3 times as long. So, but that's just, the basic idea. And so the things that you can do in there are, I call this one thing trailing arguments, which is like quite nice because you don't want code to finish this way. You can avoid this, of course, by naming things and putting it into variables, and that's a good thing to do. But to some extent, it also helps if you can just do this kind of stuff, and I will show that a bit more later. And then there are short lambdas. So there are many different flavors. So there's the first one, which looks a lot like even the stuff that even Java added. Even Java added. So yeah, you just have a few identifiers and you use this arrow, and that's what that gets translated to. And then there's a slightly different syntax with metadata, which sometimes is nice to use. And there's with the elf metadata, in that case actually returns the expression, but that's only to have kind of a symmetry between procedures and functions, to use that distinction. And there's another way of writing short lambdas. What you're going to do is just to decompose what you're getting with a switch statement, then you can write it down this way. And what's actually going to happen is that, these things are not going to be called x and y, they're just some temporary names that are going to be generated, so it doesn't conflict with anything. It's going to be __ T10 130, and then you can be sure that it doesn't conflict with the outer scope. But this way, kind of, you don't have to write the function and pick an argument name that you actually don't care about. Because the first thing you do is look at what is inside. And so here we see these two things combined, trailing arguments and short lambdas. So you can, for example, this is how you write a click handler, or there you see a switch statement. So you just load something from a URL and to handle it to look whether it's going to be a success or a failure. So yeah, you can do the normal stuff. Then extended loops, which is something I added a while ago. Like you can iterate in any direction that you want, or do multiple things at a time. So by default, as soon as one of the loop targets has run out, the whole loop stops. And the other thing that you can do is, here with this for, you can provide an expression that is a fallback. So in the first loop, as long as there are bananas and monkeys, we just feed each monkey one banana. And in the second loop, if there are any bananas left, then we feed them to the first monkey, basically. So he's going to be the fat guy in the group. Then there's the key value iteration, which, funnily enough, looks a bit like in PHP. I actually think that this could really be added to the language because like map comprehensions look like that, map literals look like that. I think that would be great. And then what you can also do is you can just add an arbitrary counter to the loop, which starts at 0 and then goes up, because like it's a thing that, how many people have had a variable defined before a loop, and then the first thing that they do in the body, they increment it. So yeah, that's just the way you would do it. And also, I had to unroll these for loops into while stuff anyway, so doing that, I thought, like, why not optimize this stuff? And this is something that's similar to what Franco proposed some 3 years ago, that you can in some way some hardware hints how to optimize loops. And this can be done with some metadata, which defines an initialization and a condition and update, much like in a C loop. And then this is going to be used to generate the loop. And this is like, for example, this is the optimization code for arrays in PHP. And so what you see is like there's like a lot of native calls and stuff like that, and then it writes a loop that will iterate on the underlying native array and get some speed up, which usually is between factor 1.5 and 4. And the best I was able to get was factor 40 faster for lists on Flash, which actually starts to make a difference. And 34 string maps in Java, and I think it was 10 for lists on Nico and things like that. And because it's like it doesn't construct the iterator, it doesn't allocate the object, it doesn't call the next and has next functions, which also are slow on static platforms because the iterable is just a type def, not an interface, and things like that. So the compiler is actually getting smarter and inlining some of these things, but this works for your code as well. So it doesn't have to go into a backend or anything. You can add this on your own collections. Partial implementations are a nice thing, somewhat like traits, if you will. Anybody here used Ruby a bit? No? Okay. So this is like what it could look like. You have this interface called an enumerable, and it has to have a fold and a map and a for each and say length property. And they all have implementations that if you read through the code, you're going to see that it all goes down to for each in the end, which also has a default implementation, and that just assumes that the class is going to be iterable somehow by some magic. Okay, that's what the for loop implicitly assumes. And when you implement the interface and you don't provide an implementation, then it's just going to use that from the interface. Like all the bodies here, they're just sucked out, stored, and when you implement the interface and don't actually implement it, then it's going to be pasted right back in. And in this case, it would like, if you just implement this, it would tell you that this is not iterable in an implementing class, because the for loop would get generated, and of course that doesn't really make much sense. And they can also have dependencies. So if we assume the interface that we had, we can like say, we can add these kind of members. So you have an iterator which is used only by for each, which means that if the for each default implementation is taken, then please generate this as well, unless there is an iterator. And for the iterator as well, generate these elements if the iterator method is used from the partial implementation. So this way you can like define all kinds of default behavior and mix that like all together, because you can implement multiple interfaces, and then the stuff that you did not provide is going to be pasted in. So it's like possible inheritance or call-out traits. It's a great way to shoot yourself in the foot, but it's also a nice way to reuse code. One thing I like that accomplishes something similar, and which I prefer because it uses true composition, is syntactic forwarding. We now have something similar for abstracts. But what this does is, like, if you have a member in your class, you can just forward certain calls and fields, and there's like a whole range of things that you can put into the forward class. You can also use regular expressions and things like that. Like, for example, forward only the fields that end with get, or something like that. And then you can just nicely hide away things. So my preferred example is if you have to implement event dispatcher on Flash-like platforms, then usually you create a dispatcher, and then you're going to implement all the methods by forwarding the calls by hand. Okay, you would just have an event dispatcher, put a forward in front, and then everything gets forwarded there, like this. What it does is generate the methods with the arguments, and the body only does the call. That's it. This is one thing that I like. Function options. So you can have an object literal as a default argument somewhere. And what it actually does is change this in a way that there's no default argument, but instead you have a type, and then you can call this function with essentially the only things that you need to supply is username and password, and the other things are default values. Like you have that a lot in JavaScript APIs, where you can configure things with one argument that is an object with many values. But like this is type safe and a bit faster to write down. Okay, so yeah, those were the things in the plan. I'm almost done. I'm almost done. Well, okay, yeah. Okay. One small project that I did with is this thing, ASPOP extensions. And what this does is like just reduce the boilerplate involved in using STOP. So it automatically connects, creates missing tables, missing columns, and initializes the SPOP. It does actually some really weird things to accomplish the initialization in the right order, but I did it. All you have to do is just do this, and then you're done with all the boilerplate. You can just define your SPOP classes, and the app is just going to magically start and do the stuff all the things that I explained in the tutorial by itself. Then you can configure it a bit with a URI. You can tell it to either use MySQL or SQLite, or to actually look in another directory, because sometimes you need to share this configuration. And there's another nice thing which works well with that. Tink template, which is a set of, a compile time macro, which supports a syntax very similar to the hex template syntax, so it's easy to switch over. But it allows for switch and while and for and var, like the whole package of hex stuff. And the templates are actually turned into true hex classes that can also implement interfaces or extend classes. So you can also like write implements tinklang, and then you can get the language sugar in there if that's what you want. You just add this to your build. There's no support for import and using yet, but there is an open issue because that actually requires some changes in the macro API. And this is what a template file would look like. So you actually see we declare static stuff, right, some functions, and all this. And this is actually a runnable web page, if you will, because you see it has a main function which does a dispatch, hex dispatch, and that will go into do defaults, and that will just use the index function, which then uses other stuff to construct the web page. But it's like self-contained, so you're not. I mean, it's a good idea to separate things, but you're not forced to have things like differently, because in this case you would just have one file which defines the template and the routes and stuff like that, and the other would define what a post actually looks like the data layer. That's the, and you don't even have to have that separation, but you really shouldn't go any better, I think. And so you can see some functions, when the declaration ends with 2 dots, then it's going to be template syntax, and when it doesn't, then it's going to be a plain function. And what you don't see here is the export being set up, because that's what you would use auto export for. Then you would essentially be done. You just plug those things together. You have kind of a bit of a web framework without a boilerplate, but you can use one thing or the other. You don't have to use export. I mean, the stuff basically also works on Node.js, whereas I use that for Node.js stuff. And there's one nice trick I'm using that I would like to share. For escaping, it actually uses abstracts. So because you have the issue, like you have stuff that comes out of another template and you don't want that re-escaped again when you use it into a new template. And the way you do it is, there is just an abstract, which is HTML, which when you give it a raw string, will escape it, and then it is HTML, and then it's going to be passed around as HTML by the type system all the time. So it's really applied just once. The knowledge about the value being escaped or not is held by the type system, and that's quite helpful. So in the future, I'm still hoping to add more tests to the code and more modules, and hoping to find a few more uses for the new stuff. I mean, the old library has gained some 17 stars or something, most of it lately, since the stuff is becoming obsolete. More contributors. I mean, obsolete in the sense, like if you're using this, I plan to maintain it forever, because I have my own project that are deployed in production and that need to continue running, and some incremental updates. And if you want to join, just write me a mail. Join now.